So, other important pins that you have in 8255 are this A0, A1 and CS bar pin. So, A0 and A1, so they are used for selecting individual ports of 8255 and CS bar is the chip select. So, if the CS bar line is high, so your 8255 is actually not activated. So, it will not do any work. So, this while CS bar selects the end, so we can, so if you so your decoding logic, so you should select this CS bar properly. So, what I mean is that if suppose this is the microprocessor or microcontroller that you have and this is your 8255, then these address bus lines that are coming out from from your microprocessor. So, that should go through some decoding logic. So, this may be a decoder, this may be a decoder and this decoder should select this 8255 chip. So, this is the CS bar line. So, for selecting this line, so decoder should put a 0. So, decoder should be programmed in such a fashion that for a particular address bit combination this 8255 will get selected and accordingly. So, maybe I can say that if this if I say for a simplistic case, if I do not have this decoder, so I can just take the A15 line of this from this microprocessor and connect it to 8255. So, this A15 may be connected through some inverters. So, put a inverter here. Okay, let me draw a fresh diagram. So, what I am telling is that okay, this is the processor and this is the 8255. So, what you can do, you from the address bus you take this A15 line and connect it to the CS bar line. So, whenever this A15 bit is 0, whenever this A15 bit is 1, so this will be 0. So, 8255 will get selected. So, provided your entire memory is located in the lower half of the total address space. Okay, so, you can say that okay, I will be setting this A15 equal to 1, it will mean that I am going to do the 8255 operation. So, this CS bar line, so this selection has to be generated by the decoder. So, here it is a very simplistic one. Ideally, if you have got a more detailed situation, like if this is the processor and from here the address bus is going, some of the address bus lines are going to the decoder. So, this is the decoder, some of the address bus lines are taken here and then this has got a number of chip select and these individual chip selects are going to individual memory chips. So, they are going to different memory chips and some of these decoder lines may be dedicated for connection to 8255. So, this way also you can figure out like what is the exact address of this 8255, that based on this decoding logic that you have incorporated here, the address can be found out. However, this A0 and A1, so these are the two bits that are to be set for selecting the registers within 8255. So, within 8255 we have got 4 main registers. One is the control register and the rest are the different port registers. So, if you are so control register is required for configuring the 8255 chip in different modes and these port registers A, B and C. So, they are actually for putting the values onto the ports, or if you want to read the content from the port onto the processor. So, you can use those addresses. So, depending upon your address setting, so the individual port will get selected. So, we can okay, I will take an example and try to explain what may be the port addresses. Like say if I have got that 15 bit 16 bit address and I can say that okay, so these two bits are say A0 and A1, these two bits are A0 and A1 and this rest of the bits are there and this is the bit A15. So, I can do it like this, I can put if I say that in my case whenever A15 is equal to 1, it will mean that 8255 will get selected. That is for the rest of the rest of the modules or rest of the memory modules and all that. So, I have got this A15 bit equal to 0. The decoder will not select those modules if A15 is equal to 1. So, this selects the 8255. Now, if you look, so if this part, this A0 A1, so A0 A1 when it is 00, okay. So, one possible address is say 1000, 0 0 0 0. So, that way I have got say this A15 so that is the 8 bits, then all these are 0. So, this is the 16 bit address bus. So, you see that this is basically 8000 in hexadecimal. So, I can say that if I connect like that, the A15 line connects to the CS bar of this the inverted A15 line connects to the CS bar pin of 8255, then this port A address is turning out to be 8000. Similarly, if this bit is A0 is 1, if A0 is 1, then the port B will be selected. So, this address is 8001, port C is 8002 and this one is 8003. So, this way based on your decoding logic and this A0 and A1 bits of the address bus connected to A0 and A1 of your 8255 chip. So, you can find out the port addresses. After that, if your microprocessor writes something to this particular memory location 8000, so that means it is accessing port A. So, if it is writing something to 8003, that means it is doing it is writing to the control register. So, this is the technique. So, we have got this CS bar as active low, and when CS bar selects entire chip, A0 and A1 will select the specific ports. So, these pins can be used to access ports A, B, C or the control register. Now, this A, B, C ports, so they can be used for input or output data, and control register is used for controlling the operation of these 3 ports. Okay. So, we can have this 8255 operate in various different modes. The first mode is the mode 0 or simple IO. So, this is the most popular mode, and almost all the applications that you have mostly. So, that they will be using this port this mode 0 of 8255. So, in mode 0, any of the ports A, B, C lower and C upper, they can be programmed as input or output port. So, input port or output port, and all bits are out or all are in. So, you cannot do it individually. So, either all the 8 bits of port A are output and all the 8 bits of port A are input. So, there is no bit selection, though we have said previously that port C is the bit addressable in some mode, but in mode 0 that is not true, that is true for a particular mode only. So, in all the entire port is configured in the same way, either it is input port or output port. Unlike 8051, where these ports P0 to P3 they have got this bit controllability. So, here we do not have that feature. Then we have mode 1. In mode 1, this port A and B can be used as input or output with handshaking capabilities, and this handshake signals will be provided by bits of port C. So, handshaking capability means you can say you can put the data onto the data bus, then from one master device when you are putting into slave device, then when the data is put accordingly the strobe signal is given, then the receiver it will receive that value and it will put another acknowledgement and all that. So, that way it will go. So, all those things are controlled by port C. These handshaking signals are given by port C, and port A and port B. So, they are used as the data values, they are used by data port. Then we have mode 2. Here port A can be used as bidirectional IO port with handshaking from port C, and port B cannot be used in mode 2. So, they can be they can be configured in mode 0 or mode 1 only. So, we cannot have this mode 2 with port B. And there is another interesting mode which is known as bit set reset mode or BSR mode. Here you can control the individual bits of port C. Okay. So, that way if you are really looking for the bit level addressability, so we have to go to mode 4, which is the mode 3, which is the BSR mode or bit set reset mode. So, the first job that we have to do is to set the control register. Now, I have said that 8255 has a control register where you have to program properly, so that you can it can be the ports can be utilized by the microprocessor. Now, in this case we have this entire control register can be divided into 2 groups. So, group A and group B. In group A, we have got port A and port C upper bits. Okay. So, you see the port A and port C upper bits are controlled by this group A setting, and group B setting controls port B and port C's lower bits. Okay. And there is another bit in the group A register which is called bit D7. So, here if this bit is 1, it will mean IO mode, and if it is 0, that means it is BSR mode. If it is in IO mode, in that case these bits D6 and D5, so they will identify the mode, like it is 00 is mode 0, 01 is mode 1 and 1x is mode 2. So, that way we can select, like in the previous slide we have seen that we can have mode 0, 1, 2 or BSR mode. We did not say explicitly mode 3. Okay. So, that is BSR mode. So, for setting BSR mode we have to set this D7 bit to 0. This D7 bit is 1, then you can select these other bits, and accordingly the mode will be set. So, if you want to set this port A as input mode, then this bit D4 has to be set to 1. If you want port A as output, then this D4 bit should be 0. Similarly, port C upper, if you want to set it as input port, then the bit should be 1, D3 bit should be 1, otherwise D3 bit should be 0. Then this group B, we have got 3 bits D2, D1 and D0. Out of that, D2 is for mode selection for group B. So, it is mode 0 or mode 1, and then in mode 1, in mode 0 you have got this now after the mode selection. So, you can control individual ports, like port B can be set to input or output, and port C lower part PC3 to PC0, they can be set as input or output by controlling this D0 bit. So, this way by setting the proper control word, so you can configure all the ports of 8255 and for different input output purpose. The most commonly used term is IO mode, that is 0, IO mode 0. Okay. So, the BSR mode is also not that common. So, 8255 the applications that we will see, mostly it is using this IO mode and in mode 0. So, that is why it is a Intel, they call it the basic input output mode. So, it is so much used that it is called it has got the name basic input output mode. In this mode, all ports of A, B and C can be programmed as input or output, and a given port cannot be both input and output at the same time. Okay. So, this is an example. So, suppose we want that all ports of A, B, C they are output mode. Okay. So, in this case, if all ports of A, B, C are in output mode and in mode 0, so you can see in the previous setting. So, this is I want IO mode. So, this bit should be 1. So, this bit should be 1, and then so it is mode 0. So, these two bits are 0, and then this port A is all this is in output mode, port C is also in output mode. So, this is again mode selection. So, 0 is mode 0. So, this is 0, and this is also output mode. So, this is also 0 and this is also 0. So, if you do that, you see the control word we are getting is 80 hex. Okay. So, that way we can say that when we are setting when we are doing this setting, that all port bits are in output mode, all ports are in output mode, then this is the control word. On the other hand, if you say that port A will be input, port B will be output, PC low should be output and PC high should both of them are output, but port A should be in input mode. So, if port A has to be in input mode, so again this is IO mode. So, this has to be 1, this has to be 1, then mode 0. So, they are mode 0. Now, port A is in input mode. So, this has to be 1, and port C is output mode. So, that is 0. So, this is again mode 0, port B is also in mode 0, and this is also 0. So, the pattern that you get is 9 0. So, let us see what pattern we have got there. So, you see that pattern is 90 hex. So, this way you can have this individual ports settings by controlling the control word setting. Now, So, we can now have some connections in which this the 8255 chip can be programmed in any of these 3 modes that we have seen. So, first of all we have to see the port address assigned to the ports ABC and the control register. So, this is the called the mapping of IO port. So, this is the first thing that we have to do, like to which address is it connected, the how to access this individual ports. So, this is a typical example. Suppose the connection is like this, that we are having this 8255 and this A0 and A1 lines from our address data bus. So, you see that port A port 0's bits are connected to 74373 and port 0 bits they have got alternate function of this multiplexed address data bus, lower order address and data bus. So, they are actually connected to this through this buffer. Through this buffer I am getting this A0 and A1 lines stable. So, those lines are connected to the A0 and A1 pins of 8255 and this P 2.7 from port 2.7 I am getting the line A14 and that is connected to this 2.7 is actually A15. So, this is not A14. So, it is connected to the CS bar line. So, this A15 line. So, if it is P 2.7 A15. So, A15 line is basically going to inversion of that is going to CS bar. So, whenever this bit is 1, so this 8255 chip will be selected. Then this read bar and write bar lines are going and these are the settings. So, this is the connection. So, this reset of 8255 should be connected to ground, read bar write bar line should be connected to this. So, this particular connection, so this type of connection is called memory mapped IO, because the 8255 will be visualized by 8051 as a memory location only. So, whenever this A15 bit is 1, it will mean that it is 8255. So, this is A15 not A14. So, whenever this A15 bit is 1, so it will be going to 8255. So, we can use it for memory access. These 8255 ports can be used as memory access and we can use the MOVEX type of instruction for getting access to the 8255 locations ports. So, so this is the thing that we have got. So, if we have connected A14, so actually there is a problem with the previous diagram and this particular table. Okay, so, this A14, so if you connect, then the A15 line this should be, if it is A14, then this one should be P 2.6. So, this one should be P 2.6. So, for that assignment the next table is valid. Okay. So, this table you see that if we have set this A14 to 1, then our 8255 chip will be accessed and this A0 A1 those bits are 1. So, I can say that port A is the corresponding location is 4000 hex. There will be many locations, in fact, that the folding concept that we have discussed previously. So, they will have the we can have this there will be folding, because all these bits are do not care. So, all of them will be coming to the port A of 8255 and then this A0 and 1 being 0 and 1. So, 4001. So, that is port B, 10 is that is 4002 is the port C and this control register will be at 4003. The control byte for if we want to put all ports as output, then we have seen that the control word setting is 80 hex. So, with this we can try to write a program where we will be sending the pattern say 55 hex and 22 hex, the 55 hex and AA hex to all the ports continually. That is, we want to complement the port bits. So, how to do this? First, we have to put the control word to the control register. So, this move A comma 80 hex. So, this will configure this will move the pattern 80 to this A register. then we load this DPTR with the control register address. Control register port address was 4003 for the particular decoder setting that we have done. So, now this MOVX at the rate DPTR comma A. So, this 80 hex which was there in A register will go to the address 4003. As a result, the control register will get 80 and all ports will be configured as output. Then we get the value 55 hex into the A register and we move that and get in the DPTR the value 4000. So, 4000 was the address of A register of the port A, and so in the next instruction when we do move at the rate MOVX at the rate DPTR comma A. So, this 55 hex which was in A goes to the location 4000. So, that goes to the port A. We increment DPTR, so that now it points to port B. So, again the same thing, we put the 55 hex value onto that port B, increment DPTR again to come to port C, and we put this value this A value into DPTR. So, that is that 55 hex goes to the port C. Then we complement A. So, all bits of A are toggled. Now, in the A register you will have the pattern AA. So, we put a delay routine and then SJMP again. So, we come back to this point where we will be again outputting the pattern AA to port A, then AA to port B, AA to port C, again this complement will take it back to 55. So, this way this program will be doing the operation. So, it will be putting the proper values onto individual bits of the port. Another important feature that this 8255 has is the bit set reset mode. So, this is a unique feature of port C and the bits can be controlled individually. So, if you it will allow you to set to set high or low any of these PC0 to PC7 bits. So, you can see first of all this D7 bit this is the control register setting. So, the D7 bit must be 0, then because in that case it will mean that it is a in BSR mode, bit set reset mode. Now, this D6, D5, D4, so they are not required because these mode settings are meaningless. If a bit set reset, if D7 is 0, so it is BSR mode. So, this mode selection of port A of group A, that does not have any meaning. So, they are by default we are setting it to 0. Then the next 3 bits they will select the bit that you want to set or reset. Okay, so, there are 8 bits. So, you can select these bit numbers by putting this bit select accordingly. Then if you want to set this bit, then this D0 should be 1, if you want to reset the bit it should be 0. So, this way you can control these individual bits of this port C and you can set or reset those bits. So, suppose we want to write a program in which we want to generate a pulse of 50 millisecond with 50% duty cycle on PC4, that is port C's bit number 4. So, first thing that we have to do is put 8255 in BSR mode and bit D7 will be low and PC4 be high. So, that is the setting. So, this is that D7 bit which is set to 0. Next 3 bits do not have any meaning, and so then I have to put the bit number. So, this is bit number 4. So, it is 100 and then we want to set it to high. So, this is setting it to high. So, PC after doing this A register has got this value. So, if you move this value so if you move this control port value onto, so load control register port. So, this will be moved to this, the control register address is moved to R1 and then MOVX A comma at the rate R1. So, to this control port we will be writing this value. So, that way this PC4 bit will be set, then we put a delay, then we have set the, now we have to make that PC4 0. So, this control setting there should be a hash here, the hash is missing. So, this control settings of this particular control setting will make this PC4 equal to 0, and then the same thing R1 has got the control port address. So, at the rate MOVX at the rate R1 comma A. So, this will be moving this control of content of A register onto the port C, then a call delay. So, it will be delaying this. After this there should be a loop around this. So, that is not shown here. So, we can do that. So, it will be continually looping this operation, and so this entire body has to be repeated. So, this way we can use this 8255 to generate pulse with 50 millisecond delay. So, 50 millisecond delay can be controlled by this delay routine. Okay. So, that is not shown here explicitly. So, you can we know how to generate those delays by using timers or using soft delays, etc. So, we can do that. So, it is 50 millisecond pulse width and 50% duty cycle. 50% duty cycle is ensured here, but 50 millisecond is not shown explicitly. So, we can do that.